Mr. Moore's math class!
Good afternoon and welcome guys to Mr. Moore's online math class. That's right, this class is all about you learning maths when it suits you best. And we have got plenty to get through today. We're going to be learning all about simultaneous equations. So let's not hold back any longer, let's get stuck straight into lesson. But before we do get stuck into the lesson, guys, what I actually want to tell you is a funny story about something that happened to me a couple of years ago. Now, when I actually go home, what I do is I go and I put the TV on mute, alright, and I'll just walk past it every now and then. And I kept seeing this show that I thought was all about simultaneous equations, and this is why I thought so. Now, this is the mistake I made, because I thought that this actually happened to look a lot like this. That is the point of intersection between two lines. And I thought the whole TV show was based on simultaneous equations. So you could imagine the look on Andrew O'Keefe's face when I went up to say my first no deal, but I actually said this.
Simultaneous equations.
Yeah, sure, I may have looked like an idiot at first, but everything worked out for me in the end. Now, as I alluded to in that story, we use simultaneous equations to find the point of intersection between two lines. That is, where two lines cross. Now, there's actually three strategies that we can use in order to be able to solve simultaneous equations. The first one is the graphical method. The second one is the substitution method. And the third one is the elimination method. And now, it's time to have a look at the substitution method.
Alright, so it's time to do some worked examples on simultaneous equations, but before we do that, let's just have a look at the three methods that we can use in order to solve them. Now, the first one is the graphical method.
Now, I'll actually go through this method with you in class, as it involves using a calculator.
But to be fair, this one is actually quite rare and we will rarely use it because there's actually other methods that we'll generally ask you to use in terms of solving it algebraically. Now, to solve the simultaneous equations algebraically, there's two other methods. We've got the substitution method that you can see here, and the elimination method. Now, both methods will work quite well, but sometimes it's better to use the substitution method over the elimination method. Now, the easiest way to be able to tell is basically use this method when we have or can get a pronumeral on its own. So what I mean by that is if you come down here to these questions here, what we can do is we can have a look and we can see if there's any pronumerals on their own. So for example, you can see that the y here is on its own in both these questions. So what you could do is you could write y equals 3x plus 2. Instead of writing y here, you could write the 3x plus 2 because we know that they're equal. Alright, having a look at this one, once again, you've got a pronumeral on its own being the y here. Alright, you can have a look here that the y is not actually on its own, but what we could do is we could write negative 7x plus 2 because y is equal to that wherever you see the y here. And if we have a look here, you've got 2y plus x equals 4 and 3x plus 2y equals 7. Well, what you can see is that the x is actually on its own. We don't have any coefficients out the front. So that means we could rearrange this equation to get x on its own and then substitute whatever x is equal to in for this equation here. To use the elimination method, well, the only time we use this really is when we do not have a pronumeral on its own. Alright, if you have a look here, you've got 2x plus 3y equals 7, 5x minus 2y is equal to 6. So you can see that there's coefficients out the front of both the x's and y's. Now in this case, what we need to do is multiply either one or both of these equations by a number in order to be able to add or subtract one of the terms away from each other to end up with just one term. Once again here, you'll see that we've got coefficients out the front of the x's and y's, which means that we'll actually need to use the elimination method again. So the challenge essentially is basically choosing the correct method to use in order to make life easier for yourself. I personally find the substitution method easier wherever possible, but both the elimination and the substitution method will work quite well, and the graphical method you'll only ever use when you get actually asked to do it using your CAS calculator, or to show it graphically. Right, so let's have a look at this question. Solve the following simultaneous equations, y equals 2x plus 5 and negative x plus 3y equals 25. Right, let's have a look at this first of all. We'll have a look to see if there's any pronumerals that are on their own. Alright, well we can see here straight away that you've got your y on its own, that is, it doesn't have a coefficient out the front, so you've got y equals 2x plus 5. What this essentially means is we can actually substitute all of 2x plus 5 in for wherever it says y. Alright, so we'll call this one equation 1, and we'll call this one equation 2. And what we're essentially doing is we are putting equation 1 into equation 2. Alright, so let's write out equation 2 just on its own first of all, negative x plus 3y equals 25. And now wherever we see the y from equation 1, let's write out what it's equal to, that is 2x plus 5. So you get negative x plus 3, and instead of writing the y, I'll do it in red just to make sure it stands out a little bit more. So instead of writing the y, I write 2x plus 5, because you can see that y is equal to 2x plus 5 here. Alright, so therefore that y is equal to 2x plus 5, which is then equal to 25. Alright, so it's essentially the same equation, but instead of writing y, I've written 2x plus 5, because equation 1, that's what it says y is equal to. Right, now what we need to do is we need to expand, so you get negative x plus 3 times 2x is 6x, plus 3 times 5 is 15, equals 25. Right, now what I need to do is combine the x's, so negative x plus 6x is equal to 5x, plus 15 is equal to 25. Rearrange them and get x on its own now, so what I'm going to do is I'm going to subtract 15 from both sides, and this gets me 5x when these two 15s cancel out is equal to 10, and therefore when you divide both sides by 5 you get x is equal to 2. Knowing this, now what I can do is I can say x equals 2, therefore I need to find my y coordinate when x is equal to 2 in either one of these equations. Now I can substitute x equals 2 into either equation 1 or equation 2. If we have a look at it though, if I substitute x equals 2 into this equation, I've actually got y on its own, so it will be easier for me. So let's substitute x equals 2 into equation 1. Write out equation 1 now, so you get y is equal to 2x plus 5. And substituting x equals 2 in now, so you go y is equal to 2, instead of writing x, I write 2, plus 5. Y is equal to 2 times 2 is 4 plus 5, y is equal to 9. Perfect. Alright, so now I know that my x value is 2, my y value is 9, so therefore they intersect at the point 2, the x value being 2, 9, y being 9. Right, the next step now is just to prove that that's actually the case. So what we're going to do is we're actually going to substitute this coordinate into both equations. So to check, substitute 2 and 9 into equations 1 and 2. Alright, so I've got my equation 1 and 2, so I go y is equal to 2x plus 5 is equation 1, and negative x plus 3y is equal to 25 as equation 2. I'm going to substitute that point into it now, so that is wherever I see an x I need to write the number 2, and wherever I see the y I need to write the number 9. So let's go through and do that. Instead of writing y, I'm going to write 9, so 9 bracket is equal to 2 bracket 2 plus 5. So 9 therefore is equal to 2 times 2 is 4 plus 5, 9 is equal to 9. Great, we know that that's correct because left hand side is equal to right hand side. LHS equals right hand side, therefore it's correct. What the left hand side equals right hand side means is basically if this one here is equal to this side, that is left hand side is equal to right hand side, it means that this equation here goes through the point 2, 9. If they don't equal each other, then it means it doesn't actually go through that point. Right, the next part, substituting in x being 2, so you get negative 2 plus 3, y being 9, is equal to 25. So you get negative 2 plus 27 is equal to 25. Negative 2 plus 27 is 25, so 25 equals 25. Therefore, left hand side equals right hand side. Fantastic. Because left hand side equals right hand side, it means this equation also goes through the point 2, 9. And that means if both equations go through the point 2, 9, that is 2, 9, it means they intersect at this point. Therefore, y equals 2x plus 5 and negative x plus 3y equals 25 intersect at the point 2, 9.
That's right guys, you guessed it. It's now your turn to solve the following simultaneous equations, that is y equals 5x plus 5 and y equals negative x minus 19. Remember to press pause, and then once you've done it, press play again to check your solutions against mine. Alright, so first step was to rewrite out the equations, and I write equation 1 and equation 2 next to it just so we can explain what's going on as we go. So, let's have a look. Are we looking to use the substitution method or the elimination method? Well, let's have a look at these two equations. Are there any pronumerals without a coefficient? Well, we can see here that y has not got a coefficient, and once again y does not have a coefficient here. So of course we can use the substitution method. Alright, so what we're going to do is we're going to put equation 1, that is this equation here, into equation 2. So what essentially I'm doing is I'm moving this 5x plus 5, because it's equal to y, I'm writing it down here where this y is. So I've got 5x plus 5 is equal to negative x minus 19. Alright, well let's move things around so I can get all the x's on one side. So I add x to both sides, add x to both sides, gets me 6x plus 5, and the x cancel out to leave me with negative 19. The next thing that I've got going on here is I've got the plus 5, so I'm going to move the plus 5 over to the other side by minusing 5 off each side. So you get 6x is equal to negative 19 minus 5 is negative 24. Right, last step to do here is just divide both sides by 6. 6's will cancel out, getting us x is equal to negative 24 divided by 6 is negative 4. So I now know that x is equal to negative 4. So I'm going to substitute that into either one of the equations. I'm just choosing 1 because that's the first one there. X equals negative 4 into equation 1. So I've got y equals 5x plus 5 as equation 1. Substituting x equals negative 4 now, right here. Y is 5 times negative 4 plus 5. 5 times negative 4 is negative 20. And then I add 5, it gets me negative 15. So y is equal to negative 15. Okay, so that means as far as we are aware right now, before we check it that is, that we think that these two equations basically intersect at the point negative 4, negative 15. Right, let's double check our answers now to see if we're correct. So we're going to substitute the point negative 4, negative 15, that is our x coordinate and our y coordinate, into both equations. So I've written out both equations here, y equals 5x plus 5 and y equals negative x minus 19. Substituting our x and our y, so our y is negative 15 and our x is negative 4. So you got negative 15 is equal to 5 times negative 4 plus 5. Well, 5 times negative 4 here gets us negative 20. Negative 15 equals negative 20 plus 5. Negative 20 plus 5, of course, is equal to negative 15. If negative 15 equals negative 15, left-hand side equals right-hand side, which means this line here goes through that point, negative 4, negative 15. Right, let's check it with the other line now. Y is equal to negative x minus 19. Substituting our y value of negative 15 here, and our x value of negative 4. So you've got negative 15 is equal to negative times negative 4 minus 19. The two negatives become a positive, so negative 15 is equal to 4 minus 19, and negative 15 is equal to negative 15. Therefore, left-hand side equals right-hand side. Tick. Now because both of these lines go through that point that we know, therefore the two lines intersect at the point negative 4, negative 15. And once again, press pause and solve the following two simultaneous equations, and remember to press play when you're finished so you can check your solutions against mine. Alright, so solving the following simultaneous equations, you got 7x minus 11y is equal to negative 13, and x plus y is equal to 11. Let's call the top one equation 1, and the second one equation 2. Okay, so let's have a look if we're going to use the substitution method or the elimination method. Now because there's a coefficient out the front of the x here for the 7, and the coefficient out the front of the y with being negative 11, means that at the moment it could possibly be the elimination method that we're using. Come down to this one though, we've got the x and the y with no coefficient, so it means that we can actually use the substitution method in the end after all. What that means though is we have to actually rearrange this equation, and you can choose to rearrange and get x on its own or y on its own. For this example I've chosen to get x on its own. So to do that I've subtracted y from both sides, and that's left me with the y's cancelling out and getting x on its own equals 11 minus y. We're going to call this one here equation 3. Now what we're going to do is we're going to substitute equation 3 into equation 1. So wherever we see the x here, we're going to write 11 minus y in brackets. Alright, so 3 into 1. That means 7. Instead of writing the x, I write 11 minus y in brackets. Minus 11y as per usual equals negative 13, as you can see here. Expand the brackets now. 7 times 11 is 77. 7 times negative y is negative 7y minus 11y equals negative 13. 77, well that's just going to be there as it is, but the negative 7y and the negative 11y will combine to make negative 18y equals negative 13. Okay, because we want to get the y on its own, what we're going to do is we're going to subtract 77 from both sides, cancelling out to leave us with negative 18y is equal to negative 90. Divide both sides by negative 18 now. The negatives cancel out to make it positive, and the 90 divided by 18 is equal to 5. Alright, so we now know y is equal to 5, so we substitute that into equation 3 because this one here has already got the equation for x. So we've got x is equal to 11 minus y, x is equal to 11 minus y being 5, so we substitute in 5. 11 minus 5 of course is 6, so we know that they will intersect at the point 6, 5 because x is equal to 6 and y was equal to 5 that we found here. Alright, let's just check our solution by substituting in the point 6, 5 into both equations 1 and 2. So got 6, 5, this one here is my x coordinate, this one here is my y coordinate. So I've got my first equation, 7x minus 11y is equal to negative 13. Instead of writing x, I write my 6 because I've got that up here, so I put it here. Instead of writing my y, I write 5. So 7 times 6, 42. Negative 11 times 5, negative 55. 42 minus 55 is equal to negative 13. And because left hand side equals right hand side, we know that we're correct. Alright, we've got x plus y equals 11 here, once again substituting x equals 6 from the point and y equals 5. Now 6 plus 5 of course is 11, and once again left hand side equals right hand side. Therefore we know this line also goes through the point 6, 5, and because they both go through that point 6, 5, it means they intersect there. Therefore both equations intersect at the point 6, 5.